Okay, up next we're going to convert between exponential and logarithmic form. These are pretty quick questions, but very important. You want to be able to understand the definition of logarithm, know the definition of logarithm to do this type of question. So, on number 5 here, well, let me go ahead and write it first. So the definition of logarithm is log base b of x equals y, if and only if b to the y equals x. This is the logarithmic form, this is the exponential form. So here we've got our logarithmic form. I would start with the base, so the base is 7. The number on the other side of the logarithm is the power, so 7 to the negative 2 equals 1 over 49, okay, which is a true statement. 7 to the negative 2 is 1 over 7 squared, which is 1 over 49. So that's the answer there. We're converting it to the exponential form. 7 to the negative 2 equals 1 over 49 is the exponential form of this logarithm. Okay, number 6, on that one we have a log. We're writing it in logarithmic form. The base would be 36. The power goes on the other side. And then we got 6. So the log base 36 of 6 is 1/2. Okay? So those are pretty quick questions. You just want to be able to convert back and forth between the two forms. And your final answer is the little equation that you would write, either the logarithm equation or the exponential equation, the statement of the relationship between the three variables. Okay, next up I'm going to do a couple of examples of compound interest. Be prepared to do either using the compound interest formula where it's compounded a certain number of times per year or the continuous compound interest formula. That's why I'm going to do two different ones. This one, it says that we're going to compound continuously. So suppose that this amount is deposited. So the 2,500, that's my initial deposit. That's the p-value in the formula. And the formula is going to be, in this case, since it says continuously, it's the amount is p(e) to the rt. Okay. Formula should be provided there on the test, or if you're doing it at home, you could look up the formula. So p is $2,500. The interest, that's r, is 4.25%. You have to convert that to a decimal, divide by 100. And then, of course, e is e. And then, so part A, we're going to find the formula after t years. So we're just going to set the formula up. So A is P, 25,000, times e to the r, 0.0425, times t. Okay, we just have the variable there because we're writing the formula itself. Part B, we're going to find the amount after 3 years, so we'll plug in 3. So A would be 2,500 e to the 0.0425 times 3. And we can punch that into a calculator and see what we get. So if we do that, we got 25, 0, second, natural log to get e. Make sure I type the right value, 0.0425 times 3. And there's our value, 2839.96. I always round money to the nearest cent, 2839.96. So 2839.96. Okay, going to need more room here for part C, so I'm going to erase. We'll leave that part. So part C, algebraically, using logarithms, find out how long it will take the balance to reach $10,000 if compounded continuously. So we're going to go in here and figure out the t value. So for part C, we have that the output is going to be 10,000, and the input is what we're going to try to find. Okay, so this is an exponential equation. First thing I need to do is divide both sides by 2,500 because I've got to isolate the exponential. See, that'll be exactly 4, right? 4 is e to the 0.0425t. And then we'd take a logarithm of both sides. Because it's e, I'm going to use natural log, and I get natural log of 4 is equal to the natural log of e to the 0.0425t. Natural log is base e, so these wipe out, and I get natural log of 4 is equal to just the power, 0.0425t. And then divide, and we'll have t is the natural log of 4 divided by that decimal. And we can punch that in and see what we get, and that would be our answer in years. We round it off here. So we have natural log of 4 divided by 0.0425. And so about 33, let's take a decimal place, 32.6 years. So my final answer here to part C would be T is 32.6 years. Okay. Okay, here's one that is extremely similar, but just to use the other formula, which would be A equals P times 1 plus R over N to the NT. We're going to compound it monthly in this problem. Some of the numbers are the same. I changed this to 15,000 for a different example, but part A, our formula would be A is our p-value, 2500, like the last problem. This time times 1 plus R is 0.0425. Over N, we're going to compound it monthly, so N is 12, the number of times you pay the interest per year, to the 12t. Okay, so for part A, we want the formula. We got t as the variable. Part B, we're going to plug in, let's see, 4 years. So A would be 2,500 times 1 plus 0.0425 divided by 12 to the 12 times 4. And then we can punch that in the calculator and see what we get. Okay, so we got 2,500 times parentheses 1 plus our interest, 0.0425, divided into the 12 pieces. And over the years, paid out 48 times, 12 times 4. So we get 2962.37. 2962.37. Okay. Part C, going to solve the equation with logarithms. This time our output, we want to know when's it going to be 15,000. We got our formula. And we don't know t, that's what we're looking for. So first thing I'm going to do is divide both sides by 2,500. That comes out to be exactly 6. If it's not a whole number, don't round it until the end. You can use a reduced fraction, but this comes out to be exactly 6. And then I'm going to go ahead on the other side, so I'm canceling this. And let me change color to show. I am going to compute this part by the powers, by the rules of exponents. I can compute this side. If I separate them, if I were to do this to the 12 to the t, we'd multiply. So we can separate them and do this part inside first. So I'm going to take my calculator and do that. So I've got parentheses 1 plus 0.0425 divided by 12 to the 12. We don't know t, but we can go ahead and do to the 12 here. We're going to get this number, and I'm going to use every single one of those digits because I don't want to round and get any round off error until the end. Okay, so I'm going to move that to the side. I know you can't see it now, but then I can type 1.04 337716 to the t. We still have the t out there. So we do as much as we can algebraically before we do logarithms. We go ahead and divide both sides to isolate the exponential part here. I can go ahead and do all this numerical part, but we still have t there. Then we can take a logarithm of both sides. I'm going to use natural log. So I'd have natural log of 6 equals natural log of this stuff. And by the exponent, or by the logarithm rules, we can drop t to the front. It's kind of annoying to have to write all these digits over and over, but again, you don't want to round until the very end of the problem. And then divide, and you would have t as natural log of 6 divided by natural log of this decimal number. And so I will just type that in, bring my calculator back over. Kind of a shortcut here. I just computed this, so now I'm going to do natural log of 6 divided by the natural log of the previous answer up here. You can do, let me move it so you can see the button, second, and above the negative it says answer. I can do the natural log of the previous answer instead of typing all those digits over and over again. And we get about 42 years, 42.2. So my final answer to part C would be t equals 42.2 years.